Alright, so I told you I was going to pause that video in order to work through some of these. And instead of pausing that video, I accidentally stopped my recording, which means I can either stop and save it or delete the recording and start all over again. And if you take a look, we only have 4 problems left. And I was not about to restart that whole video. So, welcome to part 2 to finish your notes. Again, I'm sorry, but I like to think smarter, not harder, so I'm just going to make this a second video. No, this does not mean that the notes is going to take 2 days. It's just I had a notes and accidentally stopped my recording. Alright, so we are going to simplify these. I told you to practice them on your own, so that means that you should have already solved them. If not, pause the video. Alright, so 20 is 4 and 5. 4 is 2 and 2. 5 cannot be broken down. Those 2's are going to come hang out with my 3 and get multiplied outside. My square root of 5 is going to come and hang out with. 45 is 9 and 5. 9 is 3 and 3. There are my buddies. That 3 is going to come out and get multiplied with the 7 that's already existing right there. Root 5 comes along with it. 3 times 2 gives me 6. So I have 6 square root 5 minus 7 times 3 is 21. I have the same number under that nice little radical sign. So 6 minus 21 is negative 15. Square root of 5 comes and hangs along. Alright, next one. Square root of 36 is actually a perfect number. It's 6. So I don't have any extras there. 48 is 16 and 3. Square root of 16 is 4 and 4. Hey, look, I got my buddies. I cannot reduce the square root of 3 any lower. Square root of 9 is actually, again, perfect, and it is 3. So I have 6 minus 4 root 3 minus 4 root 3 minus 3. So I'm going to take a look at finding the same stuff. So I'm going to look for 6 and negative 3. Those are my like terms. So I can go ahead and do the operation I see. They're on the same side. So 6 minus 3 gives me 3. Negative 4 minus 4 more is negative 8. Square root of 3 comes and hangs along. Cannot combine those two anymore. That is my final answer. Okay, 2 more practice problems. So I want you to at least try these on your own. So again, pause, try them, come back, and compare. So again, I've got variables in this one. We want to take a look at whatever radical's in there and divide by that radical when I'm dealing with those variables. So first, square root of 9 is 3. I have a 4 here. I have an invisible 2. 4 divided by 2 is 2. So that first one reduces down to 3x squared. 36 is perfect. That gives me that 6. I have 3 x's there, which is the same thing as x squared and x. I get 1x come out. Square root of x hang out below. Last group I have no numbers with the same idea, x squared and x. I end up having an x come out, 1x hang back by itself. I'm going to look for the same stuff. There's no other 3x squared, so it's just 3x squared. I look for the same square root, and I have it. I have minus 6x minus 1x, which gives me negative 7x square root x. These 2 terms have nothing in common, so therefore that's my final answer. Alright, number 8. Looking for cubed roots here. Cube roots, a little bit different. 81 is not a perfect cube. But what else is a perfect cube? Not sure what that was. I think that my video just loaded. 81 is 3 and 27. 27 is 3 and 3. Excuse me, 3 and 9. 9 is 3 and 3. So I want groups of 3 in this time. So I have one group of 3. So I have that 10 still out front, times that 3 that's coming out. Leave a little space, because I think we're going to have some X's come out. And that last 3 is left underneath, hanging out by itself. Let's take a look at those X's now. 6, can 6 be divided by 3? Yes, it can. X squared. Excuse me, 6 divided by 3 is 2. So then I end up getting 3 times 10, which gives me 30. So I have 30x squared. Square 3 in that first term. Ah! There we go. Sorry about that, guys. I accidentally hit the next page trying to scroll up. So I have 30x squared square root of 3 on that first term. So let's go ahead and take a look at pulling apart the second one over there. 24 is not a perfect cube. Let's try and see if we can get 3. 8 is 2 and 4. 4 is, oh, man. Come on, computer screen. So one more time. 4 is 2 and 2. I want groups of 3 this time. There's my group of 3. There's my lonely number to hang out by itself. I have no numbers in front this time. So it's just going to be minus my 2. I have nothing to multiply it with. Oops, leave that little bit of space. My 3 hangs out outside, or underneath. X to the 8. 8 is not divisible by 3, but 6 is. 2 left over. So 6 divided by 3 is 2, so x squared comes out. I have x squared left underneath. Eee. I got a room there. There we go. Nothing else to simplify on that one, so minus 2x squared root 3x squared. Take a look. Are my square roots the exact same? Nope. Means I can't do anything else. So ta-da! It's my answer. But Miss Kimmy, they both have x squareds in them in the front. This one has an x squared, and this one has an x squared. You're right. You're correct, student Johnny, who I don't even have. But Johnny, do you notice how we can only combine if they have the same radical? Oh yeah, Miss Kimmy, you're right. Well, because these do not have the same value underneath the radical, even though the stuff out front is similar, we cannot actually combine them. All right, thanks for coming back for part 2.